All right. Hello, everyone. Thank you for joining us today. My name is Haley Deshane, and I'm the events coordinator here at Eco Canada. And today's session is called AI Skills for the Environmental Sector. So before we get started, there are a few housekeeping guidelines for today's session to ensure everyone can enjoy and participate in our session effectively. All participants are muted, so please check your audio settings to ensure that you can hear us properly. If you are experiencing any technical issues, please use the chat function on the left-hand side of your screen, select technical assistance, and someone from VFairs will resolve it for you. Today's webinar is being recorded and will be made available on demand to you on this platform for 1 month after this event ends. Any questions that you have about the presentation or today's topic can be submitted through the chat box or question box. We will have dedicated time during the presentation to answer any questions from the audience. Finally, we want to know what you think about our webinars so we can keep improving. You'll be sent a short survey after the webinar ends. Please let us know what you think or if you have any comments or suggestions about the webinar. Now I would like to introduce you to our speaker. Joining us is Matthew Okondo. Matthew is a program coordinator and project manager at Eco Canada, where he contributes to various projects aimed at promoting environmental literacy and sustainability. Like Eco's Zavai initiative targeted at increasing public awareness and understanding of zero-emission vehicles. A graduate from the University of Calgary, Matthew holds a degree in electrical engineering with a minor in digital engineering and is registered engineer in training with APEGA. He has spearheaded several projects that demonstrate a keen interest in sustainable technology solutions, notably having led the development of lightweight and fast AI models to detect diseases in cassava plants and having designed a magnetic array using various machine learning methods for portable low-power MRI. Matthew's work exemplifies his commitment to leveraging technology for environmental and social advancements. All right, Matthew, I'll pass it off to you.
Yeah, perfect. Thank you, Haley. All right, let's get into this then. So first, a bit of the agenda. So first, we're going to kick things off with a little introduction. This is just going to cover what exactly is AI, like a definition of terms that are necessary to move on with this presentation. Yeah, just answer a few rudimentary questions and we'll paint a clear picture for the remainder of the presentation. Then we'll get into the role of AI in the environmental sector, where we'll start exploring why AI is a useful tool in the sector. After that, we'll look at some more specific examples of its application into different domains. Then we'll move forward into a quick overview of some trends in this space, followed by a look at the challenges and future insights that are relevant in this context. Then we'll wrap things up with a brief conclusion, and we'll have a bit of time for some questions. So, okay, let's get started. Okay, so we have the introduction over here. I'll answer some pertinent questions that will frame the remainder of the discussion, and we'll just explore some useful definitions, as I said before, and just clarify a few misconceptions that most people might have before we move on with the presentation. So you can go on to the next slide, Haley. Perfect. So as the question says on the screen, what exactly is AI? You've probably heard a lot about AI in the news or seen it in your everyday tech products, but I think that there's a few things that need to be set straight. So AI is not about building robots that think and feel like humans. And that's definitely a popular concept in sci-fi. And the reality is definitely much more grounded than that. So when we talk about AI, it's not just generative technology like ChatGPT that is stuff that makes headlines that everyone's talking about nowadays. And AI has actually been a part of our technological landscape for decades, a very long time. It's in the background of a lot of systems that you actually interact with daily and may not even know that is like an implementation of AI, like spam filters in your email or recommendation engines for streaming services like Netflix, Prime. Those all leverage AI technology and have been doing so for a very long time. So at its essence, AI is a branch of computer science that is all about creating machines, and I'm using the word machines here very loosely, capable of performing tasks that until now required human intelligence. So this includes things like recognizing speech, interpreting complex data, making decisions, or even driving cars, as many of you know already. But here's the thing though, it's based entirely on mathematical algorithms, which are just large sets of math instructions that tell computers what to do. Now, despite what you see in the movies, these aren't sentient machines. AIs don't think like we do. They process data and identify patterns at speed and accuracies beyond what we are capable of actually doing on paper. But it does this through those algorithms that I mentioned, not some kind of like fake consciousness or pretend consciousness. It's not magic, it's just math done the right way at a very large scale many, many times. So why is this distinction important? I think it's important because understanding what artificial intelligence really is and what it isn't can help us grasp its potential impacts and its limitations, especially when it comes to environmental applications, which we'll be exploring further in the presentation. So we can move on to the next slide. Okay, perfect. So now that we have a better grasp of what AI encompasses, we can narrow down to some important definitions, specifically machine learning, or just ML for short. So machine learning is the engine under the hood of AI. That's like a simple way of thinking of it. It's essentially what makes AI applications not just possible, but also practical and powerful. So machine learning is about building these algorithms that can learn from and make decisions based on large amounts of data. So the key part is that these algorithms improve automatically through experience and through learned data or additional data. This essentially means that they aren't being explicitly programmed for every single task like we have done for most tasks that are complex for decades. So instead, they adapt and they learn from new data that they encounter and actually get better over time. So, there's not somebody behind the hood there hard coding, say, like, this is the decision that needs to be made, or like, if this, then do that. The actual process involves the algorithm learning to make those distinctions and those decisions by itself, essentially. So some examples, just everyday examples to illustrate this. I mentioned like spam filters in your email. Those use machine learning to learn from the kinds of emails people mark as spam. So over time, it gets better at predicting what is considered spam and filters your email accordingly without any manual intervention. So it's taking that learned information and applying it like a future context. There's no person sitting behind the screen filtering these emails, and there's no hard coding in place of what defines spam and what doesn't define spam, because it's very difficult to manually create rules to do this since it takes too many shapes. And that's exactly like a task that is perfect for leveraging machine learning to train a capable AI that specializes at doing just that task. So this example showcases machine learning building what we call narrow AI. And that's AI that is essentially very good at performing one specific task with that task alone. So it's good at filtering emails, but it's not good at answering questions on your research paper. And that's what's cool about machine learning. It's not this crazy concept of creating an all-knowing system, but it's about developing specific applications that learn and adapt from data to perform specific tasks better and more efficiently. And that doesn't go to say that the end goal isn't, creating what people might call general AI, but essentially the scope that we're looking at is for these specific tasks. So understanding machine learning is crucial because it is the mechanism by which AI becomes not like a static tool, but a dynamic aid that evolves and improves and offers lots of advantages, especially in fields where adapting to new data can mean the difference between spotting a trend and missing it entirely. We can go to the next slide. Okay, so why is AI important? Why does AI matter so much? So why are we investing, time, resources, considerable efforts into understanding and deploying AI tech? And the answer here lies in the actual transformative power of AI, which I would say, and many researchers will tell you, it parallels major technological shifts in history, kind of like the Industrial Revolution or like the internet, which didn't come out, that came up pretty recently, if you think about it. So just as the Industrial Revolution fundamentally changed how goods were manufactured and distributed, and it brought about a lot of economic shifts and new societal norms, AI is doing the same thing for how we handle information and how we automate processes. And it's not just about making things easier or faster. AI is actually about redefining what is essentially possible or even feasible across different sectors. So the internet, for instance, it revolutionized communication and it turned the world into like a global village where we could share information super easily. And in a similar fashion, AI is reshaping industries by making vast amounts of data comprehensible and usable in a way that it actually wasn't in the past. And it, it enables us to solve problems that were previously too complex or too data intensive for people to tackle alone. Now, in the environmental sector, the implications for this are obviously vast, and that's why it represents the next frontier in technology. It's very essential for us to understand AI's potential so that we can harness its capabilities responsibly and effectively, and ensure that as we advance, we also progress sustainably. Can move on to the next slide. Perfect. So as we go into the next section, we'll focus on some of the specific applications of AI in this environmental space. And this part of our discussion is important because we will begin connecting the dots between, AI's theoretical capabilities and its practical, impactful applications in the environmental sector. Next slide, please. Perfect. So as I have touched on previously, the potential impacts of AI on environmental science can be easily compared to the impact of many other advancements throughout history on the field. So in general, we can look at this impact as a way of just improving efficiency, enabling more effective problem solving, and opening entirely new avenues. However, and I want to stress really hard on this, it's very, very important to acknowledge that AI is a dual-edged sword. It does bring, promising advancements, and it comes with its own set. It also comes with its own set of environmental costs at the expense. So, we've been hearing a lot about like data centers and the power that and these data centers that power AI, they consume so much energy, and the process of training these large AI models can have like a substantial carbon footprint. So there's like a critical balance that we need to highlight here. We need to be able to leverage AI's capabilities in the environmental sector, but we also want to understand that we need to manage its environmental impact, because that environmental impact is very big and it is very serious. So for sustainability experts, understanding AI's capabilities and implications is not just beneficial, but it's also necessary, because AI can help us optimize, resource management, reduce waste, and it can help us make more informed decision about conservation efforts. It can predict environmental changes with greater accuracy, help us respond more effectively to challenges like climate change, habitat loss, biodiversity decline. Yeah, so that being said, let's go on to the next slide here. All right, so current environmental challenges and AI's role. So in our conversation about AI's role in the environmental sector, it's essential to recognize the global challenges that we currently face. And these challenges revolve around the overconsumption of resources relative to the natural production capacity, which is obviously a fundamental issue that's impacting our planets. So we're talking here about, the excessive use of fossil fuels, which depletes these non-renewable resources. There's a plastic pollution, which is a pervasive issue that affects our oceans, wildlife, and health. We're also dealing with substantial food wastage, which raises serious ethical and sustainability concerns, given the number of people who face food insecurity worldwide. There's unsustainable mining, the use of toxic chemicals, both of these which they severely impact ecosystems and biodiversity. So these activities disrupt habitats, they pollute environments, and they can have long-lasting effects on natural systems. And these are just a few specific examples, and I'm sure that there's so many more out there. And the question really is right now, how does AI actually fit into this equation? Next slide, please. Okay, So let's go through these, one by one. So first on the screen here, we have resource optimization. So the first critical application of AI is in resource optimization. So AI technologies can help us use our natural resources, such as water, energy, and raw materials more efficiently. By analyzing usage patterns and predicting future demands, AI systems can optimize the allocation and consumption of these resources, essentially reducing waste and ensuring that production aligns more closely with actual needs. For as an example, the smart grids that are being implemented now, and these are actually powered a lot of times by AI systems, and these can dynamically adjust energy supply based on real-time demand and weather conditions, and essentially this is significantly enhancing the efficiency of energy delivery. So next we have the predictive capabilities. So with advanced analytics, AI can process these large amounts of environmental data from climate models to pollution levels, and essentially you can use this to forecast potential environmental impacts and risks. This allows us to implement early intervention strategies. For instance, AI can predict the spread of wildfires or the likelihood of flooding, and that can enable quicker response that can save lives and protect property. And these predictive models are very important for planning and preparedness, and they allow communities and governments to react before disaster strikes rather than, in its aftermath or while it's actually happening. Next, we have monitoring and control. So AI plays a very crucial role here in the continuous monitoring and control of environmental parameters. So, through sensors and satellite imagery, AI systems provide real-time data on air quality, water quality, and wildlife movements. So this continuous stream of data supports quick decision-making and effective management of ecological resources. So as an example, AI-driven monitoring systems, they can detect, say, like illegal logging activities in like a remote forest, or they can track water pollution sources, faster than traditional methods can. And this can enable like a timely enforcement of actions and remediation efforts as needed. Next, we have process improvements. So in terms of process improvement, AI enhances the efficiency of environmental processes ranging from waste management to energy distribution. By automating routine tasks and optimizing operations, AI can reduce human error and boost operational efficiency. So just to give an example here, waste management, AI can help sort recyclables more effectively. And in energy management, AI algorithms can optimize routing and distribution, as I had mentioned previously, to minimize loss and to also reduce carbon footprint. So the last point here is insights and analysis. So lastly, AI's capability to provide these deep insights from large amounts of data is extremely valuable. So these insights guide sustainable practices and policymaking by identifying the most effective strategies and predicting potential outcomes. AI tools analyze environmental data to uncover trends and patterns that might not be visible otherwise, and this can help policymakers to draft regulations that are both effective and adaptable to the situation. This could involve analyzing the impact of, like various conservation efforts over time, or modeling the potential benefits of, say, proposed sustainability initiatives. Sorry. Now, each of these applications is certainly transforming how we approach environmental management, and by harnessing this new technology, we can not just enhance our capabilities, but we can also pave the way for more sustainable and resilient environmental strategies. Next slide, please. Okay, so as we move forward here, we can focus on the integration of AI in actual environmental projects. So this part of the presentation is going to explore various real-world examples where AI technologies are actively being used to improve sustainability and conservation efforts. Next slide. Okay, perfect. So we can start off a bit broad here, so with some areas of impact for the integration of AI into environmental projects. So if we look first at AI in agriculture, some examples of its utility might be say yield optimization. So AI models can predict optimal planting times to maximize yield. Machine learning can also identify potential crop diseases early, allowing for timely interventions. And I think, as Haley mentioned in my introduction, that's something that I've worked on in the past. So there's also resource allocation, to increase efficiency, reduce waste. If we move on to biodiversity monitoring, there's species tracking. So AI-powered image recognition monitors endangered species and habitat changes from, satellite imagery. There's also habitat preservation. So here we can leverage predictive models to help forecast areas of ecological importance that might need protection. Another area could be climate change mitigation. So there's a lot of emission monitoring tools out there that employ AI to detect major sources of emissions, like globally or locally as well. And of course, a very popular application is climate modeling. So these technologies, they can enhance the accuracy of climate models, and they can help predict and mitigate the effects of climate change a lot, a lot better, and or not necessarily better, but possibly more efficiently than traditional models can. Next slide, please. I think we may have skipped over one slide there. Oh, okay, there should be a slide in between those two. So if you can just go back to the last slide and I'll just talk about this. So why exactly is AI right for environmental projects? So we touched on a few points in an earlier slide, but I want to bring your attention to these two other points. So they aren't on the screen, but just I'll talk about that. So these are certainly relevant when it comes to projects, specifically to projects in the environmental space. So the first point is the scalability and flexibility of AI. So that's definitely one of its most significant project advantages. Essentially, this means that the same AI tech that you can use to track climate change on a global scale, you can also adapt that same technology to monitor local, air quality or water safety. So this scalability is important because environmental issues don't respect borders. They can be, as localized as like a polluted stream in a small community, or as expansive as rising global sea levels. And moreover, AI's flexibility allows it to be tailored to specific environmental needs and project-specific outcomes, which is really important. Next thing would be cost efficiency. So the ability of AI to automate routine tasks is a game changer, of course. So by taking over repetitive and labor-intensive tasks, AI can free up human resources for more complex decision-making or on-the-ground conservation efforts. This automation extends from data collection and analysis to the enforcement of environmental regulations. So AI also optimizes resource allocations, as we've mentioned before, and that can also lead to cost efficiency. So for example, AI algorithms can analyze weather data and soil conditions to recommend the precise amount of, say, water and fertilizer that you might need for agricultural fields. And that can reduce waste and reduce costs as well. And essentially what we're doing is minimizing human error and enhancing that operational efficiency. And that saves money, but also improves the effectiveness of environmental projects. Next slide, please. Perfect. So in these few upcoming slides, we're going to look more specifically at environmental monitoring. So first, we're going to focus on water and air quality monitoring. So AI models are increasingly being used to predict contamination levels and track pollution sources in real time. This capability is essential for preventing public health crises and managing natural water resources more effectively. So for instance, AI can analyze data from multiple sources to detect anomalies that may indicate contamination, such as unusual chemical levels or like biological components. And a prime example of this technology in action right now is Aquaside's Apollo. So this is actually an AI system that provides these real-time insights and predictive analytics for water utilities. So this system helps in optimizing the treatment process by predicting demand, and it detects potential issues before they become, serious to the point where we have to like mitigate. And it's not just about, reacting faster to problems. It's also about, proactive management, which can significantly enhance the efficiency and safety of water treatment operations. So turning our attention to air quality, these tools are pivotal in analyzing vast amounts of data collected from air quality sensors dispersed throughout different places. So these tools can forecast pollution levels, smog events, and even like the dispersion of hazardous pollutants in real time. So this kind of predictive capability is crucial for cities to manage public health advisories effectively, and they can allow authorities to warn residents about poor air quality, like days in advance. And an effective tool in this area that we've looked at is breezometer. I'm not sure how you pronounce that, but yeah. And this uses AI to provide this real-time air quality monitoring. So this tool analyzes environmental data and essentially predicts these air pollution levels, as we've mentioned. And what this does, it offers these insights that can, help cities or municipalities or individuals make these informed decisions beforehand to protect their health. Like just throwing in an example here, given like a predicted episode of high pollution, a city can issue warnings beforehand, or they can limit like vehicular traffic or recommend staying indoors. And all of this is driven on those forecasts that under the hood are powered by machine learning AI. And in both of these cases, so in both water quality monitoring, air quality monitoring, AI is not only improving the accuracy of these environmental assessments, but it also enhances the ability of authorities to implement these timely interventions. And it is this proactive approach that is transforming how we manage environmental risks. And they can make cities safer and also healthier for residents by, through this proactive approach. Next slide, please. There should be two other slides in between these two. I'm not sure why they're not showing up on your end here. Okay, if we can just go back to the previous slide, I can just speak about them then. So the next point I had here, which is also AI in environmental monitoring, it's more so about wildlife and habitats. So let's turn our focus to this. And obviously this is an essential element of maintaining biodiversity and ecological balance. So let's start off with wildlife conservation. So AI technologies, they're making significant strides in this field. So through the use of AI-enabled cameras and drones, we are able to monitor animal populations and their migration patterns with, accuracy that we haven't seen before, but also minimal human intrusion using like drones or cameras. So these systems can process images and videos to identify species, count individuals, and even detect health conditions in some cases, which is crucial for effective species management and protection, of course. So an example of AI in action here is there's this tool called Conservation Metrics, and it is essentially a project that uses machine learning AI to analyze data collected via sensors that are actually already deployed in the field. So this system currently, it monitors wildlife health and population dynamics in real time, and it allows conservationists to make informed decisions, super quickly. And this kind of technology is vital in environments where conditions change rapidly and the well-being of the species is continually at risk. So moving on to habitat monitoring, AI plays a pivotal role in assessing habitat degradation and encouraging regrowth. So satellite imagery combined with AI analytics, image recognition, can allow conservationists to observe vast areas of land and track changes in vegetation, water bodies, and terrain over vast periods of time. So this capability is essential for detecting things like logging, illegal logging, like encroachment or changes in land use that might not be visible or easily accessible on the ground, or might be difficult for a human to identify. So a notable initiative in this space is Global Forest Watch. And this is a platform that utilizes AI to analyze satellite imagery, as I mentioned, for monitoring deforestation and forest recovery on a global scale. So by processing these large data sets that it has access to, it can help identify critical areas where intervention might be needed, and it can enable, timely action to prevent further damage or to initiate like restoration projects. And as for the next slide, which again we don't have here, but I can just talk about it. So the next topic under the environmental monitoring is climate modeling. And I'm sure people have heard a lot about this, and this is one of the most critical applications in the field. And this is where AI not only showcases its robust capabilities, but also highlights its indispensable role in addressing one of the most pressing global challenges, climate change. So AI dramatically transforms that traditional landscape of climate modeling. By integrating, again, it's always about this large amount of data, from satellite observations, whether it be like, temperature measurements, atmospheric data, historical weather patterns. AI can enhance the accuracy of these climate models by taking all this data. So it allows these systems to predict long-term climate patterns with a higher degree of precision that we've seen in the past. The ability to accurately forecast future environmental conditions is crucial for preparing for climate impact that affects all sectors of global stability, from agriculture and water resources to urban planning and disaster management. So what are some of the benefits of AI-enhanced climate models as opposed to, traditional models? So one of the biggest challenges in climate science is dealing with the complex interactions within climate systems. They're extremely complicated. There's so many different moving parts and so many different variables that can influence things. So AI methods are known for excelling in this area, and they can process and analyze these complexities more effectively than traditional models that have been used. And this capability reduces prediction errors and leads to more reliable forecasts. AI systems can also process data much faster than traditional methods, so not just necessarily accuracy, but also the speed of this processing, which means that they can integrate real-time data into climate models. And the speed is obviously crucial for adjusting predictions based on new information as it becomes available, allowing for quicker responses to emerging climate and weather conditions. And this rapid process helps mitigate the effects of sudden climate events like unexpected severe storms or heat waves. And lastly, the enhanced forecasting capabilities provided by these tools, they can be very important tools for critical decision making. So governments and organizations, these predictions inform strategies in public safety, infrastructure development, and emergency response as well. So, for instance, accurate predictions of flood risks can lead to better prepared communities, and of course, that leads to saving lives. And similarly, understanding future climate trends can help urban planners design cities that can withstand new climate realities, and this can promote long-term sustainability and safety. Moving on, a standout example of AI in climate modeling is actually a system called Climate AI. And this platform harnesses the power of deep learning to offer advanced predictions on weather impacts over extended periods. And these capabilities are particularly beneficial in sectors like agriculture, where knowing the likelihood of things like drought, floods, or ideal planting seasons can make a significant difference in yield outcomes. And similarly, water resource management relies on accurate weather predictions to ensure adequate water supply and effective flood and drought management. What is really interesting about models like that of Climate AI is that they're capable of providing these incredibly accurate forecast models at much faster speeds than traditional forecasting models. And importantly here, with less compute power and energy expended in doing so, which ends up saving both money and time. And this is obviously a really strong example of AI tools moving us in the right direction. Next slide, please. Perfect. So let's move on to the next section, which will focus on current trends in the adoption of AI, with a special emphasis on the environmental sector, of course. Next slide. Perfect. So let's break down how these technologies are being integrated and the impact they're having on our capabilities. So the fusion of AI with Earth observation technologies like satellite imagery, it has greatly enhanced our ability to monitor and understand environmental changes on a global scale. AI algorithms analyze this data to provide insights into things that we've mentioned before, climate trends, deforestation, ocean conditions, and of course more, as we have seen within this presentation. So this integration allows for, an increase in accuracy, uh, reduction in response times, and that leads to comprehensive environmental monitoring, and which is essential for effective management and mitigation strategies. One of the key developments facilitating this integration is the advancement in satellite edge computing. So this technology allows data processing to occur directly on satellites rather than after that data has been sent back to Earth. So the result here is, significantly faster processing and significantly faster transmission of environmental data, which is crucial during events that are climate related. Yeah, so, as an example, in the event, like say we have like a hurricane, edge computing enables that quicker analysis of the weather data and allows for faster and more accurate storm tracking and response strategies. Furthermore, the adoption of things like digital twins and AR platforms, it represents another trend that goes hand in hand with AI, of course. So digital twins essentially create virtual replicas of environmental systems that can be used for simulation and analysis, and it offers a powerful tool for understanding and interacting with complex environmental dynamics. So these simulations can predict the outcomes of various scenarios, such as the impact of natural disasters on human activities, on ecosystems, and it can aid in better planning and decision making. And similarly, adjacent to this, augmented reality platforms can enhance the way that scientists and the public interact with these complex systems. So by overlaying digital information onto the real world, AR provides a more intuitive and immersive way to visualize and understand the changing environment. These advancements, they highlight the potential for even greater impacts as these technologies evolve every single day. We've seen how fast these things change. And yeah, they're doing so at a super fast rate. And by enhancing our monitoring capabilities and improving our interaction with Earth systems, AI is setting the stage for more informed and timely responses to environmental challenges. Next slide, please. Yeah, so as we continue to explore these trends in adoption, it is clear from recent reports that there has been a significant upsurge in its use across various sectors. So notably, the environmental sector has seen a marked increase in the integration of AI systems, which can be largely attributed to its profound capabilities to process and analyze vast amounts of environmental data sets efficiently. So why this upsurge? The answer lies in this data-intensive nature of the actual field of environmental monitoring and environmental management. So because these AI tools are uniquely capable of handling large volumes, not just large volumes, but also very complex data, they can provide these insights and they can enable dynamic responses to environmental issues in a way that people would find very difficult by themselves. AI also detecting patterns and anomalies that might have been missed by, like a human analyst, and it can help predict things before they pose a broader risk. So in terms of accessibility, there is a strong trend towards making AI technology more accessible. Innovations are continuously being made to reduce the computational demands, which in turn lowers the cost of these technologies. And this is vital because it means that smaller organizations and even individual researchers are increasingly able to leverage these powerful tools that were previously only available to large corporations or like government bodies. And moreover, these advancements are making it easier to deploy AI on a wider scale. So simplified interfaces, improved UIs, more robust like cloud-based services, they allow for the rapid setup and scaling of AI applications. And this broadens the scope of its impact and enables it to reach more areas, especially like, underdeveloped regions that can benefit greatly from enhanced environmental monitoring. Next slide, please. Perfect. So as we move towards the end of this presentation, so let's shift our focus a bit here from the adoption and benefits of AI in the environmental sector, more so to the challenges and like some future insights. And it's important to recognize that while AI offers substantial benefits, there are also significant challenges that we must address to fully realize its potential. In these few slides, we will explore some of these challenges in depth, including issues like, high energy consumption, which I did mention at the start of this presentation. There's obviously things like data quality and bias, and there's also, disparities in the technology. And after that, we'll look forward, consider the future of AI in the environmental sector. So next slide, please. Yeah, so starting us off here, one of the most pressing challenges that we face with the widespread adoption of AI, and of course, this is particularly important to the environmental sector, is the high energy consumption associated with training large AI models. So this is a critical issue because it presents an inherent contradiction. While we use AI to combat environmental issues, the tools themselves can contribute and do contribute significantly to carbon emissions. So specifically, the training phase of these models, especially those that require, processing huge data sets, it's extremely energy intensive. Training a single advanced deep learning model can consume as much energy as several cars would over their entire lifetimes. And this is due to the computational demands required to process and analyze this data repeatedly over numerous iterations. So the carbon footprint associated with these computational processes is substantial because much of the world's data centers rely on non-renewable energy sources. And despite advancements in renewable energy, the rapid expansion of AI technologies and the data centers that support them often outpace that shift towards greener energy solutions. So how exactly do we go about addressing such a challenge? And there are several avenues that are obviously being explored. So researchers, they're continuously working on developing more energy efficient algorithms that require less computational bandwidth to train. So techniques like network pruning and quantization, they've shown a lot of promise in reducing these energy demands of these systems. Encouraging data centers as well to adopt renewable energy sources for power is also a crucial strategy because aligning AI operations with sustainable energy practices, this can help mitigate the actual environmental impact significantly. And obviously, while this is not necessarily like a solution to the root problem, we can also think about like carbon offsetting, which can play a role in balancing out the emissions generated by the AI training process, at least, in the short term. Next slide, please. I think there should have been a slide before this. Haley, if you can go back one. No? Okay. So that's okay. Just move on to the next slide. So we'll look at technological disparities here. So as we continue to explore the challenges associated with the adoption of AI, it's really important to address the issue of technological disparities. So this refers to the uneven distribution of the technology, AI technology, and expertise between developed and developing regions, which can lead to and exacerbate, these global inequalities. So in many developed regions, access to cutting-edge AI tech, high-speed internet, robust data infrastructures, and obviously skilled human resources as well is essentially very common. And these regions benefit from the advantages that AI brings. And, contrasting that, developing regions often face significant barriers to accessing these technologies. So limitations here can include the lack of infrastructure, or lower levels of technological literacy, and of course, economic constraints that prevent the adoption of these technologies. And this gap means that while some parts of the world are using AI to advance their environmental efforts rapidly, others are being left behind, and they're struggling with outdated methods that are less efficient and often more harmful to the environment. So the consequences of the disparities, they're very important to note. Regions without access to these new technologies may face challenges in managing natural disasters, or predicting weather patterns, or conserving biodiversity as effectively as regions with access, which can have ecological and human impacts. As environmental challenges mount, often disproportionately affecting less developed regions, those without advanced tools who aren't on the cusp of technology, they essentially become comparatively less equipped to cope with the impacts of climate change and other factors. And that leads to the worsening of that socioeconomic condition and disparity. And then disparities in technology access, they can hinder global efforts towards sustainability and climate goals, as not all regions are able to contribute equally to mitigation and adaptation efforts. So in terms of bridging this gap, how exactly can these disparities be addressed? So for starters, developed countries and international organizations can help play a significant role in transferring technology and knowledge to developing regions. This can include funding initiatives, training programs, and partnerships that build these local capacities. So developing AI technologies that are tailored to the specific needs and conditions of developing regions can make adoption more feasible as well. Now, these solutions should be, of course, cost effective, and they should require minimal infrastructure and be easy to use and also maintain. And last, but definitely not least, governments can create policies that encourage the adoption of AI in environmental management. So this could involve things like subsidies or tax incentives or regulatory frameworks that promotes technology transfer and investment in AI. Next slide, please. So one thing I want to touch on before we reach on to future prospects is there's another challenge that is extremely important, and it is a critical challenge across all sectors employing AI, and that is the issue of data quality and data bias as well. So the effectiveness and reliability of AI, they're heavily contingent upon the quality and diversity of the data that it actually receives. So AI systems, they learn and make decisions based on that data that they're fed. And if this data is incomplete, if it's outdated, or if it's poorly curated, it can lead to models that are inherently inaccurate or also biased. And this is a universal problem across all AI applications, whether it be like financial forecasting or healthcare diagnosis, but also like wildlife tracking and like things like climate modeling. So in the environmental sector specifically, poor data quality can lead to flawed predictions about, say, like weather patterns or misidentifications in wildlife conservation or incorrect assessments of pollution levels. On the other hand, bias in data is another pervasive issue. If the data used to train AI models is not representative of all possible scenarios or populations, the outcomes will inherently favor certain groups or conditions. And this can lead to models that perform well in controlled or familiar environments, but fail miserably in others. Like, just as an example, an AI system that is trained predominantly on data from an urban setting might not accurately predict or analyze environmental conditions in rural settings, for example. But what are some strategies that are being employed to help mitigate this? So obviously the first thing would be improving how data is collected. Ensuring it captures a broad spectrum of variables and conditions is obviously fundamental. This might involve diversifying the sources from which data is drawn and increasing the granularity of the data collected. These models should undergo rigorous testing across a variety of scenarios to ensure that they perform consistently and accurately in fast scenarios. So this obviously includes things like stress testing models under atypical conditions to identify these potential biases. AI models should also not just be static. They need to be continuously updated with new data that reflects changing conditions and new insights. This is particularly crucial in a field like environmental monitoring, which is dynamic and new conditions are evolving rapidly. And finally, developing and adhering to ethical guidelines for AI development can help ensure that considerations of fairness and accuracy, they're prioritized. Now, talking about these future prospects here, as we consider the immediate efforts and ongoing initiatives in enhancing AI for environmental applications, it is important to recognize that substantial progress is already being made right now in these three key areas that I've highlighted here. So currently, as we speak, researchers and developers are actively working on creating models that require less power, compute power, and this obviously reduces the energy usage and environmental footprint. And as we know, this is important for promoting sustainable practices within the AI field itself. And they're already yielding more energy efficient algorithms that can be deployed with a lower resource cost. Right now as well, governments and international bodies, they're also developing and reinforcing these regulatory frameworks that govern the ethical use of AI. And these frameworks, they aim to ensure that AI is used responsibly, particularly in sensitive areas like environmental management. And these regulations are critical for preventing the misuse of AI and ensuring that it contributes positively and not negatively towards these goals. And the last point here would be this efforts to democratize AI technology, and it's currently making it more accessible across different regions and different sectors. And this includes initiatives to lower the cost, but also simplify the deployment and provide training to diverse user bases. And these efforts are crucial for ensuring that the benefits of AI in environmental management are widely distributed and not just limited to technologically advanced regions. These ongoing initiatives represent significant strides towards making AI a more integrated, efficient, and ethically governed tool. And by focusing on these current efforts, we ensure that AI not only advances technologically, but also does so in a manner that aligns with global sustainability and equity objectives. Next slide, please. Okay, so we're at the end here of the presentation. We started a little bit after schedule, so let's wrap things up really quickly here and take a look at some of the high-level takeaways. Next slide. Yeah, so it's obviously clear that AI is not just a tool of the future, but it already is a transformative force, and it's reshaping the environmental sector. By enhancing predictive accuracy, optimizing resource use, and improving monitoring and control systems, AI-driven technologies are paving the way for more effective and sustainable environmental management practices. As for the key takeaways, here's a few things that I want to point out. So AI technologies offer significant advancements in managing energy, waste, and natural resources, to name a few, directly aligning with and contributing to our sustainability goals. So the capacity of AI to process and interpret vast data provides unprecedented insights that significantly inform things like policymaking, conservation efforts, and scientific research, and it can help guide crucial decisions in environmental management. And as we advance, it's imperative to address the ethical concerns and dimensions as well, and strive for equitable access to AI technology, ensuring that its benefits are distributed broadly across different regions and communities. Next slide. Yeah, so I just want to end on this quick statement right here. So the integration of AI in environmental strategies presents a promising pathway to address global sustainability challenges. Continued innovation and responsible deployment of AI tech are both essential to maximize their benefits and mitigate their potential risks. Next slide. Perfect. So thank you everyone for your attention through this presentation. I hope that you found it at least somewhat informative and that it has hopefully given you a bit of a deeper understanding of the role AI is playing in transforming the environmental sector. So we have about 3 minutes here, which I know is not a lot of time, but if you have any questions, feel free to ask and I will try my best to answer them. So thank you everyone for joining me.
Thank you, Matthew. So we do have a couple questions in the chat. First one, will we reach a point where AI itself is able to optimize how it operates in order to minimize its own environmental impact?
That's a very, very loaded question. So, I'm not any kind of, domain expert by any means, but the idea behind AI improving itself is definitely an outlook that if you do your research and if you look at different research papers, not just specifically within the domain of environmental impacts, but that is a point that we are already reaching where you can use AI to improve itself, not to this scale where, it's like this uncontrolled chain reaction, but that is a thing that is being explored for sure. And when it comes to the environmental impact, I'm certain that there's going to be a future in which we can develop AI that can then suggest ways to mitigate its own environmental impact. Maybe go ask ChatGPT right now and ask it how to mitigate its own environmental impacts. Maybe it'll give you an answer.
Thank you. So it looks like that's all the time we have today. We will pass on your questions to Matthew and get back to you with any answers that he says. But thank you everyone for coming. Our next webinar, EP in the environmental sector, tips and tricks to benefit your growth using your designation, is in 1 minute. So go on and join that one. Thanks so much, Matthew, and bye everyone.
Thank you, Haley. Thank you, everybody.